Welcome back, guys. We're going to move into the idea of thinking about that little fraction of total energy expenditure which is dedicated to protein use during exercise. So we're going to take a little look at that section now. Only a few slides in this little one, so it's just a short little section, but worth discussing nonetheless. So, as already discussed in some of the earlier slides, protein use during exercise, it only contributes a relatively small amount of energy during exercise. And the amount essentially depends on what nutritional state the individual is in and the exercise intensity of the training or competition that is being completed. And this particularly applies to those, the branched chain amino acid that oxidize within the skeletal muscle rather than within the liver. So let's take a little look at what it is exactly we are talking about here. The protein breakdown usually increases modestly with exercise. So you can see here we have 2 hours worth of exercise taking place here. And we have two different states. We have a carbohydrate loaded state whereby the individuals have consumed lots of carbohydrates in their diet prior to completing this 2 hour bout. And we have individuals who have completed the 2 hour bout in a carbohydrate depleted state, so their muscle glycogen and their liver glycogen stores are going to be compromised. And you can see exercise here in a carbohydrate depleted state causes this kind of increase in protein catabolism, or the breakdown of proteins within the body. And we can see here that the measurement that's being used on the y-axis is the plasma 3-OH butyrate concentration, which essentially only occurs when you've actually utilized protein as a fuel source. So essentially the rate of which protein is being used during exercise is largely dictated by the macronutrient availability to the individual. So if you have a high glycogen availability, the likelihood is you won't utilize quite as much protein because you already have a fuel source that is preferred by the muscle to be able to utilize. However, the second that you move into a carbohydrate depleted state and you exercise for a prolonged period of time, then because your glycogen stores have been compromised, you still need to maintain a circulating blood glucose concentration of anywhere between 4.5 and 5.5 millimoles. And in order to achieve that, the body then starts to utilize non-carbohydrate precursors for the creation of new glucose molecules. We call this process gluconeogenesis. And in this particular example, we're utilizing the branched chain amino acids in order to increase the rate of which gluconeogenesis is. Now, protein synthesis increases following both endurance and resistance type exercise, and the type of adaptation varies depending on the stimulus. So with endurance exercise, we tend to see an increase in the amounts of mitochondrial proteins that have been synthesized post-exercise, and with resistance exercise, we tend to see an increase in the myofibrillar proteins, which essentially increases the amount of muscle mass that is available to the individual. And we can see that demonstrated here. So if we had muscle protein synthesis in percentage of muscle per hour, and we can see that with the completion of exercise, we see a net loss of muscle protein synthesis, so we're actually losing muscle. But in the recovery period, we actually see that muscle protein synthesis is increased, and it's increased quite dramatically. So around anywhere between 10 and 80% is increased 10 to 80% following aerobic exercise, and this can remain elevated for around about a 24-hour period following the exercise bout. So exercise itself is quite a potent stimulator of muscle protein synthesis, which kind of makes sense, particularly in the recovery period. However, we need to ensure that there's a sufficient amount of macronutrients available, and in particular in this case protein post-exercise, in order to ensure that we get maximal rates of muscle. So for those who undertake the nutrient metabolism unit in in level 5, it's his second year, particularly on H&E, you'll get the opportunity to find out more about this type of. So that was just a very short video looking at the role that protein can play, because it does play a small proportion. It does have a small contribution to total energy expenditure, and is a unique macronutrient that's being utilized during exercise. But obviously that changes, and the amount that it contributes to total energy expenditure changes depending on the macronutrient status of the individual, and therefore the habitual dietary practices of the individual. So when we come back for the last section of this little series of talks, we are going to talk about that habitual dietary practice. So what are people doing in their day-to-day lives which will actually start to alter the substrates that they utilize during exercise. So I'll see you across there, guys.